Hi everyone, my name is Hana Matatov. I'm a PhD student at the Technion. So the main subject of this work is visual misinformation detection. But before we start with the detection part, first let's understand what it means visual misinformation. There are two main types of visual misinformation. First, the publication of manipulated images. For example, spliced images, photoshopped images, or memes. The second type of visual misinformation is the publication of images that appear out of context. For example, this Facebook post presents 3 images, and the caption says that these are Honduran migrants on their way towards the United States, and they're burning the flag of United States. And you wish to know if it's true or false. And if you were a journalist, you also need to decide if you should publish the story or not. In this case, this post is fake news. All of these images were taken at least 2 years before the publication of the post. And if we look carefully on the first image, we can see that it's not the flag of the United States, but the flag of Trump's campaign. Therefore, all of these images appear out of context, and this is the second type of visual misinformation. Okay, great. This journalist found out the truth. He won't publish the fake news story after he spent efforts and understand that it's out of context. But what about this group of journalists that see the Facebook post the first time? They need to do the same process all over again. Our collaborators at Cornell Tech conducted interviews with journalists at New York City and found out that the journalists don't have any collaborative and efficient tool to share their findings regarding visual misinformation. All of this inspired us to, not to mention journalists from different newsrooms. All of this inspired us to use advanced computer vision techniques to enable collaborative visual fact-checking. So let's take a look how we developed our solution. The journalist user examines a certain query image that he suspects it may be visual misinformation. Then we show him the most visually similar images from 3 different sources. First, images that appear on web. Second, images that appear on our internal social media index. These images may have been deleted from web at the time of the query. That's why we have them in our storage. The third type of images is those that already were flagged by other journalists. This way, we support this collaboration that I just talked about. At any point, the journalist can further inspect each of the images and he can add his own feedback. Now, let's talk about the interesting, important part, how we implemented this, how we did it. So first, we crawl images from different social media sources. Then we compared between 3 different visual feature extraction methods. First, we used the orb local descriptors. Then we thought we may benefit from global features, so we used deep learning, and we took a pre-trained VGG16 convolutional neural network. And the third method, we decided to build and train a new neural network that was trained for our needs. So we defined a custom-designed network that inspired by the Siamese neural network architecture. And we used each of these 3 methods. It's a method for visual feature extraction of the features of the images that we crawled at the first step. Then we took these features and indexed them by using the Facebook AI similarity search. All of this was the offline step. The online step starts when the user is searching for a query image. The online step must be fast because we're talking about a real-time system that the journalist can use daily. Therefore, when the journalist is searching for a query image, we start the online step. We are using the k-nearest neighbor search and retrieve the top n most visually similar images to present them to the user. So now that I explained how we did it, let's see what was our results. Let's see some benchmarking. So we have 5 data set of images. Each image has several instances. It has the source image and several manipulated versions. For example, here you can see an original image from the news website Dataset and 3 of the manipulations that we automatically generated. For example, cropping the image or changing the colors, and there were many more. This example is from the spliced images dataset. You can see the original image on the left, and on the right side, it's the manipulated version. So you can see that the splicing was adding the second tower on the right side. The third example is from the Photoshop battles dataset. This dataset includes images from the Photoshop battles subreddit, where users generate and upload several manipulated versions of the source images in this subreddit. Okay, the goal of the evaluation was to benchmark the performance of the retrieval process. But we had few challenges. First, we had to decide what would be the best metric, because we knew the journalists wished to see the most visually similar results, and we knew that the journalists wished to see them in the top ranks. But we had no ground truth, because for each of the query images, we couldn't know if it has similar images in our index or not, and we could not check this because the index is very big. Therefore, we had to take a subset of 80,000 source images, and we used them as the index for the evaluation step. Then we sampled a subset of 1,000 images among the 80,000 and used them or their manipulated version as query images. Those, for each of the query image, we certainly knew that it has at least one similar image in our index. At this step, we could check, given a query image, we could examine the ranking of its source image in the retrieved results and calculate the recall value. So let's see the results. We compared between the 3 feature extraction methods and saw that when using VGG16 convolutional neural network, we attained the best results, which was more than 85% recall value at top 3. In addition, there were differences in performance depending on the source of images. For example, the spliced images retrieve maximal value of recall. The news website and social media dataset received high value of recall, which is around 87%, while the Photoshop battles received only approximately 60% recall. This makes sense because the Photoshop battles is the most challenging because the manipulations in this dataset were done by humans without any constraints. But we're not sure if this is exactly the type of manipulation that appear on the context of visual misinformation. Third result, the performance varied depending on the type of manipulation used. For example, changing the colors or adding visual markups almost didn't affect the recall, but doing extreme cropping or adding extreme Gaussian noise resulted in lower recall values. To summarize, we talked about our motivation and the need of the journalist for a collaborative tool for addressing visual misinformation. Then we talked about how we designed our solution and how we implemented and developed it. Finally, we saw some benchmarking result showing that using VGG16 as visual feature extraction method resulted in more than 85% recall, which showed that we can help the journalist by using our system. Thank you very much for listening.